Welcome to the second part of acids and bases. So in the previous video, we looked at acids. In this video, we're going to take a look at bases, pH scale, and indicators. Let's get started. So in the previous video, when we were talking about the reaction of acids with reactive metals, we talked of a certain range or a certain group of metals that are able to react with acids as we described. Then there are some metals which cannot react with acids, and we talked about the reactivity series, and we said that metals that are below hydrogen on the reactivity series cannot react with acids, but metals that are above hydrogen in the reactivity series can react with acids. So what is the reactivity series? So the reactivity series is a list of metals that shows which one is more reactive. So this is the reactivity series. So metals on top are more reactive than metals on the bottom. So hydrogen is here. So all these metals can participate in a reaction where they react with acids to produce hydrogen gas. Well, these metals, copper, silver, gold, cannot take part, or a reaction cannot happen between these metals and any acid to produce hydrogen gas. So this is just a pic I got on the internet, and it has got a memory ADA. Please stop calling me a careless zebra. Instead, try learning how copper saves gold. So this is just the way to remember the reactivity series. But for me, the way I used to take it, copper, silver, and gold, I used to know that they are less reactive than hydrogen. So this is the reactivity series. With this being said, let's get on to today's topic. So what is a base? A base is a substance which reacts with an acid to form a salt and water. Remember, neutralization reaction, the reaction of an acid and the base to form an acid to form a salt and water. So even a base is such a substance. There's another way in which a base can be defined. Remember, we defined an acid as a proton donor. So even a base can be defined to be an oxide or a hydroxide that accepts a proton. So we can say a base can be defined as an oxide or hydroxide of a metal, or just a proton acceptor. So from the definition, we can tell that a base neutralizes an acid. So if you mix a base and an acid, you're going to have something neutral. You're going to have water at the end and maybe a salt. A soluble base is called an alkali. So there are types of bases: soluble bases and insoluble bases. Soluble bases are called alkalis. So we can define an alkali now in a different way, just like the way we defined an acid as a substance which, when dissolved in water, produces the hydrogen ion as the only positively charged ion. So an alkali can be defined as a substance which, when dissolved in water, produces the hydroxide ions, which is OH minus, as the only negatively charged ion. So you have a substance, you dissolve it in water, it gives you hydroxide ions as the only negatively charged ions. Then that substance is an acid. So these are examples of alkalis with their common names. So I've got sodium hydroxide, which is called caustic soda, of potassium hydroxide, which is called caustic potash. Then I've got ammonium hydroxide, which is called aqueous ammonia. Then I've got calcium hydroxide, which is called lime water. So whenever you hear lime water, just know it's a base with the formula this, and its chemical name is calcium hydroxide, just like that. Then we can also take a look at insoluble bases, the non-alkalis, the bases that do not dissolve in water. So we have these: copper 2 oxide, zinc oxide, iron 3 oxide, lead 2 hydroxide. So these are examples of bases, but they're not alkalis. Why? Because they do not dissolve in water, but they are bases. So we're going to take a look at ionization of alkalis, just like we did with ionization of acids. So in alkali dissolved in water, they produce hydroxide ions as the only negatively charged ions, just from the definition. So example of ionization of alkalis, we have this one where sodium hydroxide produces sodium and hydroxide ion as the only negatively charged ion. So this is ionization. Remember, ionization is just the process by which ions are formed in a chemical reaction. Another ionization is this one where we have potassium hydroxide, where we get potassium as a positively charged ion and hydroxide ion as a negatively charged ion. How do we now classify alkalis in terms of strength? So in terms of strength, we have weak alkalis and strong alkalis. We defined acids in terms of strength as a strong acid is that which completely ionizes in water. So even for the bases, it is the same. So strength of an alkali is a measure of its ability to produce hydroxide ions. A weak alkali is an alkali that partially ionizes when dissolved in water. By partially, we should remember that there is an involvement of a reversible reaction, meaning that when you have a situation like this, you have got an alkali here. So if it ionizes, it gives you this ion and this ion. This process is reversible. You can combine the ions to get the original reactants. So this shows partial ionization, and if you have such a base, then just know that it's a weak one. Then a strong alkali is an alkali that ionizes completely when dissolved in water. An example is sodium hydroxide. So sodium hydroxide ionizes completely to produce sodium and hydroxide ion. There is no way you can combine this in this reaction to get back the original reactant. So this reaction is not reversible because the sodium hydroxide has completely ionized. Physical properties of alkalis. So just like acids, you're going to see that most of the physical properties of alkalis are the same as that or as those of acids. One, alkalis have pH number greater than 7, while acids have pH numbers less than 7. So just to clarify my statements, the physical properties are nearly the same, but they are opposites of each other, but they are based on the same parameters. So for acids, it's less than 7. For alkalis, it's greater than 7. Alkalis 10 red litmus paper blue, while acids 10 blue litmus paper red. Remember? Third, alkalis have a bitter taste, while acids have a sour taste. And also, alkalis feel soapy or slippery between fingers. They feel like the way the soap feels. So go to chemical properties of bases and alkalis. So the chemical properties are very important because from the chemical properties, you know certain reactions and you'll be able to predict what is formed in a given reaction just from the chemical properties. So the first one is alkalis and bases react in a neutralization reaction with acids to form salt and water only. So this one was discussed at length when we were talking about acids. So for example, sodium hydroxide, which is an alkali, and hydrochloric acid, which is an acid, so we're going to produce a salt, sodium chloride, and water. Alkalis react with ammonium compounds to form a salt, water, and ammonium gas. So here is an example of sodium hydroxide reacting with ammonium compound here, which is ammonium chloride, to produce sodium chloride, which is a salt, plus water, which is a liquid, and ammonia gas. So when we're doing these bases, we had a reaction where, when we're dealing with acids, we had the reaction where an acid was reacting with carbonates to produce salt, water, and carbon dioxide. Here, when we are talking about alkalis, they react with ammonium compounds, not carbonates, to produce ammonia gas, other than the two that which has sodium chloride and water. Alkalis react with solutions of soluble salts to form precipitates of insoluble hydroxide. So if you get an alkali, remember an alkali is soluble, so its aqueous solution might be a uniform mixture, which is a mixture where you cannot distinguish the constituent or the different parts that makes up that mixture. So if you get maybe a uniform mixture, which might be like clear water, you mix it with solutions of soluble salts, which might also appear clear. You can't tell that there's salt. So when you mix them, they are going to form an insoluble hydroxide. So since this hydroxide is insoluble, it's going to come out of the solution to form a precipitate. So whenever you have a precipitate, just know that there's something insoluble which cannot dissolve. So something that cannot dissolve is going to be formed like magic. Anyway, so we have sodium hydroxide here reacting with a soluble salt here. What's going to be formed is this insoluble salt, sodium sulfate, it's sodium sulfate, and this insoluble hydroxide here, ion hydroxide. So this is the reaction. Alkalis reacts with acidic oxides to form salt and water only. So they are what are called oxides. We're going to study them in the next chapter. So there are different types of oxides. You have acidic oxides, neutral oxides, amphoteric oxides, and the likes. So acidic oxides, when they react with alkalis, they behave like acids. So they end up behaving like it's a neutralization reaction. So they end up forming salt and water. So we have sodium calcium hydroxide here, which is an alkali, reacting with the sulfite, which is an acidic oxide. They are going to form calcium sulfate and water. Next, look at pH. So pH is just a scale which helps us to tell the acidity or basicity of a substance or of a solution. So if you have a pH meter which has this scale, you put it in a solution. According to the reading on the pH, you'll be able to tell if that solution is an acid, or if it's neutral, or if it's a base. So the pH meter has numbers from 0 to 14. So in between there's 7. So 7 is for a neutral solution. A neutral solution is a solution which is not a base and it is not an acid, like water and common salt. So now that's how it is. Numbers below 7 are for acidic solutions, and numbers greater than 7 are for alkaline solutions. And the fun part is, the higher you go on alkalines, it means the more alkaline the solution becomes. So, for example, if you have got two solutions, A and B, solution B gives you 14 and solution A gives you 12. Solution B is more alkaline than solution A, which gives you 12. Also, when you go to acids, the lower you go, the greater the acidity. Meaning that if you have two solutions, one gives you a pH of 1, the other one gives you a pH of 4. The one that gives you a pH of 1 is more acidic as compared to the one that gives you a pH of 4. So that's how the pH works. So this information is what I've just described here. Finally, we take a look at indicators. So what is an indicator? An indicator is simply a chemical substance which has different colors with different substance or solutions, or it is a chemical substance which shows you different colors when you put it in different substances or solutions. So indicators are very important because they help us to have an idea of the nature of the solution, especially in this case, whether it is an acid and a base. Here are examples of indicators. So we have litmus paper, which is an indicator. So when you put it in an acid solution, it will show you red. When you put it in an alkali solution, it will show you blue. Then we have methyl orange. When you put it in acid, it will show you red. In alkali, it will show you yellow. Then we have methyl orange. Bromothymol, which will show you yellow in acid and blue in alkali. And finally, we've got phenolphthalein, which shows you colors in acids and red or pink in alkali. So these are some of the indicators. Then there's what we call a universal indicator. So a universal indicator will give you a color that is going to proportionate a certain pH value. So a universal indicator is a solution of paper which shows different colors in acidic or alkaline conditions. So here are some colors and their corresponding pH values. So on top of pH values, on the bottom of colors, red to show you. If you put your universal indicator in a solution and it shows you red, just know that the pH must be 1, 2, or 3. Orange 4, 5, yellow 6, green 7, blue 8, indigo 9, 10, and purple is for pH values from 11 to 14. So this is everything about a universal indicator. So universal indicators and indicators are used to know the acidity or basicity of a solution. Next, look at formation of acid rain. So there's rain which is very bad, called acid rain. So acid rain is formed when gaseous acidic oxides dissolve in rainwater in the atmosphere. So when it's about to rain, and when rainwater mixes with gaseous acidic oxides, then we have acid rains. So what is it that is destroyed by acid rain? Soil. The soil becomes acidic to crops and vegetation also die. So these are the negative impacts of acid rain. So the way to deal with acid rain is to use, of course, bases. For example, if you get your indicator or your pH meter, you measure your soil sample, or maybe for your garden, and you discover that it has a pH lower than 7, meaning that the soil is acidic. So you need to add a base so that it neutralizes that acid. So a base, you can add lime, which we discussed that it is an example of a base, an alkali. So you can add lime to your soil, then the lime is going to neutralize the acid, and you have solved the situation.